Hi Gotcha, this is the tutorial for a motor driver with inputs. Let's go. This is the basic code for a motor driver with inputs. So we're going to use a SparkFun motor controller to set the direction and the speed of the motor, but we're also going to use a potentiometer and a switch to control those inputs. So first we're going to define the two direction logic pins here using the constant integer in direction A and direction B as 5 and 4, and as well as the constant integer of PWM at 6. Then we're going to define the input pins as the switch pin and the pot pin. So then we're going to set all the pins as outputs here, the direction pins and the PWM, and then set the switch pin as an input. Then we're going to go to void loop, and we're going to read the potentiometer from the value of the potentiometer and divide by 4 to get a 0 to 25 range, and then store the variable as a speed variable here. And then we're also going to read the value of the switch and store it in the direction variable. And if the value of the direction is high, then we're going to drive the motor forward at a speed set by the speed variable, which will be set by the potentiometer, or else drive there in reverse and use the same speed set by the speed variable. So if it's high, it'll be a forward speed, else reverse speed. Then we're going to create a custom function that defines moving forward. Function accepts one parameter, and that will be the speed, which we drive forward, so the integer SPD, speed. And so then if the motor controller direction pin is set to forward, direction A is high, direction B is low, and write the speed onto the parameter of the SPD using the analog write function. Then we're going to create another custom function that defines the movement in reverse. Using the integer speed again, we're going to set the controller pins to reverse, direction A is low, direction B is high, and again write the speed onto the PWM using the analog write function and the SPD value. And that's
This is
it.
the Arduino board for the basic code of a motor driver with inputs. So here's the motor driver board here. So this yellow cable here connects the VM or the motor power source to 5 volts through this yellow wire to the 5 volts pin over here. And then the orange wire next to it right here connects the VCC or the chip voltage to the 3.3 volts through this red wire to pin over here. And then this gray cable right here is grounding the board that I connected to the negative column through this black wire, and that negative column to this other black wire here. Then we go to the red wire that is attached to the motor that attaches the pin BO2 on the board, which is a motor B connection to the motor, and the same with the black wire connects pin BO1, which is again another motor B connection, and then this gray wire also grounds the board. Then we go to the other side. We have this red cable here that is attaching the STBY, which is the pin for the standby high for the board, and low for the board, which is off, to 3.3 volts, again through this red wire to 3.3 volts. It's there. And then the orange wire, it's hard to see, where is it? The orange wire here connects the BIN1, which is the direction pin for motor B, and that's attached to pin number 4. See through here, this one right here, pin number 4. And then the yellow wire attaches a BIN2, which is the direction pin 2 for motor B, and that's attached to pin number 5. And then this white wire here attaches the PWMB, which is the PWM signal for the motor to control the speed, and that is attached to pin number 6. And then again we have another gray wire here that is grounding the board into the negative column, which is grounded by this black wire over here. Then we go to the potentiometer right here, and here we have it is grounded by this gray wire, again by attaching to the negative column. This green wire here is connected to the potentiometer to the analog pin 0, and then the red cable right here is attaching the potentiometer to the 3.3 volts do again this red wire. Then we get to the switch, and it's grounded by another gray wire to the negative column. Then it's attached to the 3.3 volts through another red cable right here. And this white wire is connecting it to pin number 10 so it can be an output. There we go. Right now the potentiometer is turned off, so if we turn it to the 3, we can see that the speed starts to increase. And if we go down, it decreases. And then if we switch the switch to the single pole double throw switch, different directions, and you can see it switches. So let's do that again. Switch it. I'll switch directions. So we'll clear that. That's it working. This is the modified code for a motor driver with inputs. We're going to use a SparkFun motor controlled by inputs, so we're going to use the inputs to manually set the direction and the speed of the motor. Then we're also going to have LEDs signal the direction that the motor is turning in, as well as have a servo motor show the degree of speed that the motor is at. So first we're going to define the 2 direction logic pins and the speed pin, the PWM pin here. We're also going to define the input pins as the switch pin and the pop pin here. And then we're also going to define the 2 LED pins, the forward LED and the reverse LED. And we're going to include the servo library as well. Servo, and then servo and servo 1. There's a servo object called servo 1. We have to voice that up. We're setting all the pins as outputs, so the direction A and B and PW and both the LEDs as outputs, and set the switch pin as an input. And then we're also going to attach servo 1 to pin 9 on the Arduino and set serial begin at 9600. When we get to void loop, we're going to create a variable as integer position, and then we're going to read a value from the potentiometer and divide by 4 to get a range in the 200 from 0 to 255, and store the value in the speed variable. We're then going to read the value of the switch, and we're going to use the if statement to say if the switch pin is high, then the following code will work. So it's going to drive forward at the speed set up here. So if the digital read switch pin is high, the forward speed is going to go. So then we're going to print out forward speed equals the speed that we calculated up here. We're also going to turn on the forward LED on high and keep the reverse on low so it's off, and print forward LED on. We're then going to make work for the servo, so position is going to equal 0.7 times speed, so that's the conversion from 255 to 180 degrees about. And we're going to do servo 1 right position, so it's going to turn the servo to the position calculated right here, and then we're going to print the position equals the calculated position, and then delay for 20 milliseconds to allow for movement. And if that didn't work, so then we go to an if-else statement. So else is going to reverse speed, and if we're going to serial print the reverse speed and the speed, same as the one that's going to be up top. And we're going to turn the reverse LED on high and the forward LED on low, and print out that reverse LED is on. We're going to use the same conversion factor to find position, and write servo 1, use the write function to write the position into the servo 1 to have it show the angle, and then print that out again and delay for 20 milliseconds. So then we're going to create a custom function to define the moving forward function. So then, the forward integer speed, SPD. So then we're going to have the controller direction pin set to forward, so the direction A is high and direction B is low, so it'll be forward. And we're going to use the analog write function to write the SPD onto the PWM, and we're going to print that again. So the SPD is going to be the speed at which the motor is turning, and we're going to do the same thing for the reverse. So forward reverse integer SPD. So we're setting the pins to reverse here. So direction A will be low and direction B will be high. And then we're going to write the SPD onto the PWM using the analog write function and then print it out one more time.
So here's the serial monitor working. If we pause the auto scroll real quick, we'll see that the forward speed is plugged in right now, and the forward LED is on. The position is 53. So, and then if we switch the switch, then it will turn to reverse speed here. The other LED is on, and if we change the potentiometer, we can see the numbers increase and decrease. So yeah, there we go. This is a modified Arduino board for the modified code of a motor driver with inputs. So here we have the motor driver, same as the basic code. All the wires are still the same, still grounded the same wires, and connected the motor to the same pins on the board. The potentiometers also has grounded both by the potentiometer and the switch are still set up the same way. They're both grounded by these gray wires. The red wires are both still connected them to the 3.3 volts. And the white wire is bringing the switch to pin 10, and the green wire is still bringing it to the analog pin of 0. Then we get to the two LEDs. So the red and both LEDs are grounded through the cations into the negative column here, and grounded by the black wire, which is connected to this one, and then grounded by this black wire as well. They're both connected through a 100 ohm resistor to their pins with their information. So the red LED is connected by this green wire to pin number 13, and the yellow LED is connected by this yellow wire to pin number 12. See here? And then our servo motor right here is the black wire, which is continued through here, is grounding the motor into this ground pin over here. The red wire that I have to substitute for blue wire here is connecting it to 5.5 volts by connecting it to the board here and connecting through this yellow wire that is already connected to the 5 volts. And then this white wire here that it follows through the white wire here connects it to pin number 9 here. So right now we can see that the motor is turning like a slower speed. The servo motor's not that far away, so if we take the potentiometer and we turn it, we'll see that the servo motor will turn to show the degree it's at, and the motor will increase. And if we go the other way, it will decrease. There we go. And you see that the yellow light is on, so it is in the reverse direction right now. So if we switch the switch, we'll see that the red LED will go on and the servo motor will switch directions. Again, the potentiometer will work and the servo motor will work the same way. There we go.